Recently I've acquired a new aircraft, that's the Aerosoft Twin Otter Extended, and we're going to have a Twin Otter Extended more or less authentic-ish hybrid cockpit which is going to be flyable once it's up and running without the mouse or the keyboard, cold and dark to cold and dark. I'm going to be using an ultra-wide display with track IR. I'm going to be using a realistic yoke. I'm using the Elite yoke, but no gauges by and large on the panels. It's input only. So, you know, some people will look at that and say, oh, it's not realistic, but nothing is until you get into big money. So there we are, day 1 of the Twin Otter cockpit project. More as it happens. So this is basically all my switches and stuff. Ooh yeah! We've got several of these. These are the BBI 32 bit boxes, that's what he calls them. You plug this into a USB port. It appears to Windows as a joystick with 32 buttons. Then we've got one which is not quite the same. It basically does the same thing, but it also has 8 analog inputs. So here we've got the first attempt at laying out the GPS and comms panel. It's going to be a 30 centimetres square. Obviously the switches are all just laid on. There's the original rough layout on paper. As you can see, it's got all the switches that I'm going to use on the actual panel. This is the fuel panel in the middle, and also all the rotary controls for the various avionics. The other thing we've got here at the bottom is the test panel, the main overhead panel. That's this one. It's going to be mounted up to the right hand side overhead. Autopilot, that's going to be basically in the centre just above the yoke. I'll lay it all out in a minute and we'll get a sense of the spatial kind of relationship between these things. These are just mock-ups. I'm not going to wire these up as they are. They're made on crappy hardboard just to get a good sense of the layout. Obviously the real panels are going to be constructed slightly more carefully than those. I'm going to use acrylic sheets for those. So what I've done this afternoon is I've cut the acrylic sheet into mostly into 30 centimetre squares. So these are mostly, as I say, 30 centimetre squares. For the smaller panels I've got some 15 by 30. So we're just working on the first panel. What is that? The centre console panel. To print this on an acetate we're going to need to turn it into a negative. The laser printer absolutely sucked for doing this job. Plan B, this old inkjet printer. So there's the result of printing on the inkjet printer. When that's dry I'm going to sandwich those two together between the two bits of, here's my first attempt at making up the actual panel. Once I combine these two, that's going to be absolutely stonking. Here it is, this is the lower console. It's not perfect, there's actually cracks. The top layer of acrylic's cracked. I've been basically figuring out how to work with this material. It's very brittle, very hard to drill it. Anyway, it's been a bit of an education in trying to figure out how to drill holes without cracking it. But one problem I've found is the sandwich is too thick basically. Most of the controls on this panel have these push buttons, these round push buttons. Like a lot of these switches, they're designed for a maximum 4mm thick panel. I think the toggle switches are going to be okay. It's the push buttons don't matter. I mean, these are just pushed in. They're just sort of sitting in the holes at the minute. So anyway, just looking around the back, this is constructed as a box. Obviously there's no back on it at the minute. We'll have to see for a 30 by 30 panel if that rigidity works as well. What I'm working on at the moment is the second panel. This is a much more complex panel. This is the GPS comms panel. So the difficulty with this panel is mounting the VGA screen, which I have here. To mount this on the panel, I'm going to cut out a hole which is approximately the right size. My initial, ideally I would have this sitting behind the panel. The problem with that is it requires very precise cutting of the acrylic, which I don't think I'm going to achieve. So what I'm going to do, you notice the bezel kind of sticks out by a couple of millimeters all the way around. But the idea is to cut a hole that's slightly smaller than the bezel, so I can actually have this protruding through the hole. So the bezel effectively hides the roughness of the cut that I'm anticipating, and it'll look pretty good. And here it is. That's the GPS COM nav panel. So 2 panels down, another 5 to go. 1, 2, 3, 4, 5 to go. But this is by far the most ambitious and complicated panel. Most of the panels are done now. You can see them behind me, probably, not very well. Latest one just completed today. It's not actually completed, I'm short of a few components. This is the, I suppose, top console, which is going to be directly in front of me. What I've been putting off is really designing some kind of framework within which to fit all of this stuff, and notably the overhead panels. I've got one overhead main panel, which is the one I just showed you. I've got the start panel is going to be overhead, and then I'm going to have another 60cm panel to the left of that holding the radios. This is the layout of the cockpit with all the panels shown, based around the same display that I've been using for the last 5 years, which is 3 4x3 19-inch LCD monitors. It's going to be in two parts really, and the two parts we join together. The main part, which is for this lower console with all those panels on, it's basically going to be just a flat plane essentially. So it's a framework, rather like a framework for a deck or something like that, and it'd be sloping down. It's going to be held together with coach bolts, so it's dismantleable easily if we don't have to move it. Then, you know, we'll be into the meat of the project, which is wiring it up. I'm not looking forward to the nuts and bolts of that. It's going to be a lot of work. I mean, just taking one of these panels as an example, this is the start, I mean it's essentially the start panel. Probably like 27 wires need to be soldered just as a starting point for making this panel live. When I say just as a starting point, notionally you just take the ends of those wires and plug them into the solderless contacts on the Bodner controller board. Now the problem with that is, because I've got so many panels and this all over the place, and all the Bodner boards, controller boards together, and I want the panels to be detachable, it's not going to be that simple. Otherwise I'm going to end up with lots of very long wires, and anytime I want to take a panel away to fiddle with it, I'm going to have to pull all the wires out of the controller. So what I want to do is have some sort of umbilical connection, so all the wires will exit in one bundle and there'll be some kind of connector, and then in principle you could pull that out, take this panel away, tweak it, plug it back in with minimal fuss, and all the controls are wired up again. And of course the problem with that is it doubles the work, well it more than doubles the work, triples the work really. And you look at something like the GPS board, that's just, you know, insane numbers of components. But that's all got to be done. So here we are again, and for the first time I'm actually sitting in the Twin Otter. This is the superstructure for the cockpit itself. That little tray down the bottom there, that's for the centre console, which has got the autopilot override switches and also the rudder trim. Well, I've reached a bit of a milestone now, and that is that the construction part, at least, of the cockpit is substantially complete. You know, when you're doing this kind of thing, you've got to plan for the fact that everything takes many times longer than you think it's going to take. I've got to say. The other thing I had to do really over the last week or so to get these panels mounted finally is figure out a sensible way or an effective way to do that. Basically I've just got some very sharp nails and I've cut the heads off and I've mounted them into the frame, so there's typically four or six on the longer panels sticking out. The points are just basically sticking out. So this allows you to position the panel exactly where you want it really. There's very little margin for error, and then when you've got it positioned correctly you just press it in and those little studs effectively keep it in place. And then to hold it there I've used a very low-tech method, which you might be able to discern if you look here. These are cable ties, so basically I've just got 4mm holes, cable ties, pull in the panels onto the frame and those studs keep them located precisely where you put them. So anyway, that's taken quite a long time. I've got a pretty good finish there. They're close enough. I'm going to make a dash as well. The dash is going to just sit along the top of there, overhang a little bit, so it'll tidy up that edge. This is a Leo Bodner BBI 32. It's basically a joystick controller with 32 buttons on, and today I'm just trying it out for the first time to see if it works as I expect it to work. I've also got one of the other controllers, the joystick controller that includes the analog axes. I might dig that one out as well and try potentiometer on there. I've got a toggle switch at the moment just wired up to the multimeter just to check that the switch works like I expect. It seems to. That's continuity tester. Hopefully you can hear that beep. So that's just to ensure the switch works like I expect it to. I mean, there's nothing particularly complex about a toggle switch. That's a single pole, single throw, SPST. So we're looking at the BBI32. Here it is. Handy USB lead. Going to plug it in. There you can hear that connect. What I'm going to do is I'm going to use some handy paper clips just to get me connected. I'm going to just connect up one of the switches, switch 1, and then what will we do? We'll link that up to the switch. BBI32's come up as a thing called button box. If we right click and do game controller settings on that, we will get button box interface. If we go properties, we get a test page. So what we should see is button 1 toggling with the toggle switch. And indeed we do see that. So that's working just as we expect. So next up I think we'll do an encoder. Alright, this time we've got a rotary encoder switch. Here it is, can you see that? Just about. This is a simple encoder. It basically does the function of 2 switches, left and right. The slightly more complex ones, which I have got on many of the panels, you've got a left and right and a push switch in the middle. I don't have one of those to hand, but now what we have to do here is slightly more complex. We need 3 paper clips plugged into button 1 and button 2 of the controller, and they have a common ground. So if you connect to one ground, you're connected to all the grounds. Another thing we have to do here, we need to run the BBI32 interface program. This sets up the behaviour of the controller appropriately for the type of encoder switch we've plugged in. We've plugged in the one I was just showing you, the basic 2-way controller. What we've got here basically, we're looking at pairs of inputs. So each rotary controller you plug in basically occupies at least one pair of button inputs. So as I've just demonstrated, I've plugged this encoder into the B1 and B2 inputs, so I need to go and set that up. They're all set initially to off, so I've set this to 1 to 1. That seems to be the right setting. And if I go back into my properties page for the BBI, what I should find is when I click it right, I get button 1, and when I click it left, I get button 2. So I'm going left, 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 and each left click, single click of the encoder switch gives me a single pulse on the button, and I'm going right, and a single click gives me a very reliably, and they're 1 to 1, and I'm spinning it really quickly, and I'm not getting any glitching, I'm not getting any spurious opposite direction pulses. This is obviously a high quality encoder switch, in contrast to some of the crappy switches you get on things like the Cytec boards. So that seems fairly straightforward. Let me just go back and see if I set that to 1 to 2, see if this behaves like I imagine it. Yeah, basically 1 to 2 just divides it, so you have to go 2 clicks between pulses. So we don't want that in normal operation. So we're back again. This time we've got the big daddy board. This one is the BU0836X. Along here we've got analog axes as well as all the button connectors. Alright, this time we've got the controller wired up with a potentiometer. I believe this is a 10K linear potentiometer. So we're going to use this for a volume control for my ATC comms and also for the rudder trim. So what I've done is I've plugged this in, again using 3 paper clips for each axis. This is the x-axis. We've got a ground plus 5 volts and a centre tap, that's called. So there it is, not very dramatic. That's the x-axis. Hopefully you can see that wandering left and right there. This is an interesting program. It shows you all the controllers plugged in. I've got a Logitech joystick plugged in as well, so you can see as I move that, that's quite a nice program really. Give me all the raw data, but it's this one down at the bottom left that we're interested in. This is our axis. Rotate the potentiometer, we're getting the values displayed here for the x-axis, and you can see currently displayed, if you can read that, the output value is 0. If I go all the way to maximum, we've got 64K more or less. So that all seems fairly straightforward, and I think we've pretty much got the hang of that. So we've just got the basics of the electronics mounted, and that's here on the side. So the idea here is these are mounted at more or less working height, so it's going to be easy, it's going to be less arduous, shall we say, to wire them up. And we've got USB leads will exit up through these holes in the top onto a hub at the top of the structure there, and as you'll see, that's nicely enclosed. Got the quadrants mounted securely now. A nice little frame built for those. So the power quadrant's definitely better with the Cytec original knobs on, without the extensions that I made. Doesn't look quite as good, but it works better. The friction's still not great. These are basically cheap, nasty things. As I said earlier, the levers are too close together. It's not that so much that the levers are too close together. It's really that the pairs of levers are too close. What you really would like is 2 levers, then a bit of a gap, then 2 levers. What I might do is see how this goes, and at some point think about buying a more expensive quadrant from the likes of GoFlight or PFC. Well, I'm about to do something fairly bold and somewhat destructive. This is the lead from one of my 3 throttle quadrants, and I'm going to take this pair of wire cutters and chop the plug off. Now, why the heck have I done that? Well, actually, if you take a close look at that plug, it's not a USB plug. This is a 6-pin DIN. My 3rd quadrant is actually the quadrant that comes with the Cytec yoke system, which I'm not using. It's been in the loft for a couple of years. But so basically what I'm going to do is I'm going to drive this through one of the Bodner boards, the one that has the analog axes. Alright, well that wasn't wildly successful. I had made the assumption, fairly shaky assumption, that the controller part of this Cytec throttle quadrant was all in the body of the yoke, because you remember this is part of the yoke system. That's not true. There's a board in here. I've opened it up now because I couldn't make any sense of the wires coming out the far end. So what I'm proposing to do now, you can actually see quite easily the meat of what I need. The potentiometers are mounted, they're tiny little round ones, they're mounted right here, here and here, and you can see 3 wires coming from each one, which is as expected. You've got a red, black and yellow. Yellow's the centre tap, and those wires go to the circuit board, and conveniently enough mounted on the circuit board are the push buttons. So what I'm proposing to do really is just cut everything off this circuit board. The circuit board's going to do no job except mounting the buttons. I'm then going to solder longer wires onto the wires that are coming from the pots, and I'm just going to run those out through, you know, effectively I'm going to remove this cable. This cable no longer serves any purpose, but a new cable will be made of a bundle of wires basically connecting to the potentiometers. And also I'm going to attempt to solder connections onto the, I've identified on the controller board, it's easy to identify where the buttons are mounted, and they'll all plug into the Bodner board. Alright, here we are back again. So I've done some work on the quadrant as discussed. What I've done is I've abandoned the idea for the moment, or postponed the idea of using the buttons. The main reason for that is these switches are soldered onto this circuit board. I was hoping to solder onto the backs of the solder points that you can see on the board, but honestly to solder securely onto those is too much of a pain. I don't know if it's even possible. So I'm going to do away with those buttons for now. What I've done is I've soldered up the potentiometer connections. Look nice and tidy. My soldering skills have improved dramatically in the process of making 1, 2, 5 solder joints, and it looks not quite neat, and it's quite secure now, and I've tested those and they seem fine. So what I've got to do is get those wires bundled up, exiting through the correct orifice, and then I'm going to plug them in tonight. I'm actually going to do it tonight. My first wiring for real, just as a test run. I'm going to wire this up to the Bodner board, the one with the analog inputs. So I've finally got the rejigged throttle quadrant plugged into the Bodner board, and I'm going to go over to Windows. I've stretched it across with the USB lead to my desktop PC. Going to go over to Windows, see what we see. Alright, here we are. Let's plug it in, see what we get. So there we've got the BU036X interface, and if I wiggle it, whoa, we got a Z X and Y axis. Fantastic. So that works. So what I'm doing at the moment, I'm just wiring up the first panel. This is the autopilot panel, essentially. I'm wiring up the common ground section to all the switches. No soldering as yet.
Joe, you should have gone for 1 second more. Yeah.
I've now soldered in all the common ground connections. So the next thing to do is to wire up the signal connections, I suppose you'd call it. That's basically one lead from each switch has got to come out, and then of course we take one ground from this common bus. And so the next job really in doing that is to dig out one of the 25-way D connectors, or two. I have to count up how many connections there are on there. Basically solder one wire from each of these onto one pin of that connector. I've got two rotary controls on here, and I'm just really conscious that when I get to the other end of this cable and have to plug the leads into the Bodner board, I'm not going to have any colour coding, and I need to be able to distinguish the ground. Well, I have got colour coding for the ground. I've got some blue wire that I'm going to use for the ground, so that connection is easily distinguished, but the main thing is to distinguish the two rotary encoders from the other switches, which are all just simple on-off switches. Well, the soldering for the first panel is, well, I was about to say it's complete. It's a very specific stage. I could choose that this was complete. These wires are all now soldered on the switches. I've got to basically do all those solder connections over again onto one of these. This is a 25-way D-type RS232 style connector, and this obviously sits in a little shield.
I'm sure will still be part of his role as Mark. That's what he's made his own. Talking much more overtly about climate change or deforestation or genetic modification. Don't for a moment think that that's the line.
So there it is, the first panel complete and wired up. The only thing left to do on this really is to basically test each of the switches end to end, and then of course I've got to wire up the other side of that 25-way D-type connector, and that'll be wired up to the long wires which will go from here round the corner and into the Bodner board. I'm going to have to do some work on the Cytec trim wheel. The problem with this is the same problem that you'll have with any absolute positioning trim wheel in an aircraft that uses autopilot. The Twin Otter makes heavy use of autopilot, and in particular it does auto trim when you're using things like the vertical modes they're called. Basically it's not compatible with an absolute positioning trim wheel such as this, so I'm going to have to do something about that. What I'm hoping to do is convert this, add something on so that it also drives an encoder as well as whatever it is. I mean, the irony is it is actually implemented using an optical encoding sensor, but electronics are contrived to actually make it present to Windows as an absolute, as if it was a potentiometer. So what we're looking at here is the inside of the Cytec trim wheel. You should see this large wheel here. It's edge on so you can't see it, but it's a big round disc with slots cut in it, and it's basically it's part of the optical sensing mechanism, rather like it used to work in a mouse when they were still mechanical. So on this side of the wheel we've got an infrared emitter, on this side we've got an infrared receiver, and it's got 4 connectors soldered onto the board. What I've done is I've soldered onto 2 of those connectors, and it's the two, and these solder connections on the back side of the board, so we can't see them here, and it's the 2 connections that are closest to the edge of the board in this direction. So with those wires soldered in place, I've plugged this into the USB port so it's got power, connected up my multimeter to the ends of the wires. We get pulses! So that's pretty damned awesome. That's going to do, hopefully, what I needed to do. So the next part of the challenge is to plug it into the Bodner board and see if that recognises it. And I've hooked it up to button 1 and button 2, so if I spin the wheel we're getting pulses for button 1 that way very quickly, and then spin it the other way, pulses for button 2. Fantastic! So I've been doing a little bit more work on the interior as well, and it really is an interior now. You'll notice this far side is now enclosed. As you remember with the dash, it butts up nicely against the bottoms of the monitors. I want to do something similar at the top here. I know how I'm going to do it. I'm going to have 3 different panels. They're basically going to attach onto the structure just under here. They're just going to sit, you know, because there's an angle. You need an angle there. One central panel, which is a square, a rectangle rather, and it'll just attach there, and essentially, I can't really show you what I mean here, but you attach there, and then it's just going to sit down like that, really. So it'll find its own level, obviously be the right width for the monitor, and then 2 more out at the sides. So that will give me an absolutely watertight forward view. Not sure how well you're going to see this, but this is basically what completes the feeling of being enclosed in the cockpit. So there's no, I mean the idea is there's no light visible, and you should notice the track IR mounted in the middle here. So here's that from the top of the cockpit. You can see these are the blanking plates. Here, well, there's actually 3 plates, 1, 2 and a far one I can't reach. You should be able to see the track IR spider. So another milestone, I've just finished wiring up the first panel completely, and that includes the bottom award end. This is the link cable which goes to the autopilot panel. Literally all that remains to do is to plug this into the panel, and I should be able to program this panel through FSC IPC and so on. Alright, so I'm sitting in the Twin Otter and I have plugged in the autopilot main panel for the first time ever. So I'm just going to flip switches and things should happen. There you go, joystick 0 button 19, button 16, 24, 13, 5. So that's just a complete success. You know, the first time every switch works. I've been thinking about, starting to think about the programming as well, in fact experimenting with the programming of the buttons and switches. I've got 3 of the panels done, and that's the main autopilot panel, got the start panel done, and also the overhead. And I've been experimenting really with hooking those up and programming the switches. And it occurred to me that I could just about fly it around, and that's what I'm going to do. We should be able to do it cold and dark to cold and dark without the keyboard. We've got control lock on a button here. We've got the yaw damper, which is on the lower console, so we've put that on a button temporarily here. We don't have the fuel panel, so we've got the fuel boost pumps replacing the emergency fuel cut-off switches on the fire panel. So let's do it. We're going to take off the control locks. We're going to put the beacon on. We're going to go for DC master on. Then we're going to select the DC source as battery. Now you should have seen things come to light there. What you see that's slightly anomalous is these radios are on. These are controlled by the Elite Windows driver, and I can't basically control those independently. They come on with the DC power. We can do the fire detection test. We can't do the full test because the mute button's on a panel which I haven't implemented yet. Alright, so we're going to do the engine start. I've got the track IR disabled at the moment just because when I reach up for the switches my hand blocks the sensor and it goes a bit haywire. We've got to make sure the fuel levers are off. Props we want from fully forward. Power levers are at idle. Boost pumps on. Okay, then we can go ahead and start the right hand engine. So we put the start switch to the right. We're looking for at least 12% gas generator RPM on the right hand engine. Then we can introduce fuel. There it goes. I can let go of the start switch. So that engine's coming up nicely. Same for the left hand engine. So now the engines are online, we can put the generators online. If you watch the indicators here, if I just pause that, if I turn on the left generator, the indicator goes out, right generator, that indicator goes out as well. We need the auto feather system to be armed. If you watch the indicator here, that's armed now. I want to set the altitude alert using this dial here. It's currently at 3000, I want to set it to 2600. That's because field altitude is 600. This will alert 1000 feet before the programmed altitude, so it should alert at 1600, which is circuit height. Should really set the rudder takeoff trim but I'm not doing that just for this test. Okay, we want auto feather off, we want to get the flaps in. We want to put the yaw damper on, we don't need the landing lights anymore. Back a bit more on the power, back a bit on the props. It's got a flaps 30. Whoops, not watching where I'm going there. Flare them there, a little bit high. We'll go down, we can go reverse. Stopped it dead there. So what's taken up most of my attention at the moment is thinking about the programming of the buttons and switches. We need to know about a thing called FSUIPC. For our purposes, FSUIPC is essentially an add-on that allows us an alternative way to program buttons, switches and also analog axes. Another piece of the jigsaw that we need to introduce here is in implementing custom gauges and functionality using the FSX SDK. The programmers typically use things that are called, I think they're called gauge local variables or local gauge variables or something like that. The implication of this for us is that we can find publicly accessible variables within the custom modules of the Twin Otter in this case. We can read from them and write to them, and by writing to them we can make things happen in the Twin Otter custom code. And FSUIPC has a lot of support for that. FSUIPC implements within it a facility for writing scripts, custom functions in a language called Lua, that's spelled L-U-A, and Lua in FSUIPC has functions for reading and writing these LVARs. So that closes the loop. If you think about that, you can write a little bit of code in Lua that reads from or writes to a local variable within the Aerosoft Twin Otter code and thereby make things happen within that code. Flip a switch, for example, or read the status of a switch. The last bit that I missed out earlier is that the Lua functions that you write, you can make those available in the dialog that allows you to link up functions to buttons and switches. Now what's very good news for us, somebody has put a lot of work already into doing just that, specifically for the Twin Otter. And his name's Gunter Steiner, and he's written a bunch of Lua functions that address many of the buttons and switches that we need for the Twin Otter in a way that allows us to hook them up without doing any real work. I've left out another thing here, which is Gunter's done that in a way that uses another tool called Linda. The purpose of Linda is to sit on top of all this FSUIPC and Lua kind of glue stuff and make it much simpler. Now Linda, let's talk a little bit about Linda and Lua. So Linda is going to feature in my implementation. I think I'm probably, certainly for prototyping, not prototyping, but experimenting with the initial setup, I'm using Linda because it's just very, very convenient to do that. One of the other steps along the way to deciding to do this project was I got this VR Insight panel. This has got 6 rotary controls. The way these work is when you move it left, each click is essentially a button press, and then you move it right and it's a different button press. So it basically emulates 2 buttons. Fantastic. Anything that needs a rotary control, like the Cosman window or the tuning the radios, setting the heading bugs, I did that and it was realistic. It was great, but the problem you're going to find is when you set that up on something like the heading bug on the HSI, it's really slow. It's a very nice action. These are very high, well not very high quality, they're high quality, they're sufficiently high quality rotary controls, but it's really slow. You can move it precisely, but to move it through let's say 180 degrees, it's just painful. Now if you look behind the scenes, there's a little glimmer of hope if you look up what controls are available to be mapped onto these buttons and knobs. For many of these situations, including the OBS and the heading bug, you've got an increment and decrement function, but you've got an increment and decrement fast function, which typically might increment and decrement values by 1. If it's fast, it might be by 10, or in terms of altitudes, it might be by hundreds and thousands. The problem then is, what do you do with that? you might or you might not be aware that there is the idea that you can use a button as a shift button. So in other words, you can modify the action of a button according to whether another button is held down. So FSU IPC allows you to program compound button operation. So one way of doing this is, let's say, coming back to the heading bug, you could hold down a button and twist the knob, or release the button and twist the knob, and thereby getting two different functions. And then of course I remembered, or I noticed that these rotary controls have a click, and I thought, oh fantastic, I knew there was a kind of rotary control that has an extra button click integrated. So I thought that's the answer. The rotary control operates as I've described. If you hold it down and turn it, that's your shift key. So you've got coarse control, let's say unshifted, fine control if you push and turn, or probably vice versa I think. Now the problem with that is these VR Insight rotary controls don't seem to work that way. I think it's a fair bet, if you opened this up, looked at those components, they would actually have the extra switch on them, but for some reason they're not wired up. Anyway, I knew that's possible to do, and I remembered the Leo Bodner, for example, looking at the components that are available to plug into the Bodner boards. You know, you could definitely get those rotary controls. That would definitely be the ideal solution. Well, today I've decided to wire up the GPS com nav panel, whatever you want to call it. I've got to tell you, these little dual concentric controls are an absolute nightmare to solder. Tags are very close together. So we've got this one guy. It's the only components I've got soldered so far.
Suffering strip of land, full access to the outside world.
Never going to be paid back. For every
And then they can adapt it to the Gold Coast, and I think it would be
private run, it's
Yeah.
two knits to
Specific.
it's now that feed.
And that's that panel finally done. Just finished the umbilical. This is you'll recall, the most complicated panel of the lot. This is the GPS nav comp. Got 34 components on there, and that's a total of 43 signals and one ground. 44 wires in this bundle. Next thing to do, I've got to stick the screen back into it, obviously. Bloody hell, another showstopper for the minute. I just thought, well, just put this back together. There's not enough space to put in the VGA cable. Alright, that should do it, but going to be a couple of days delay. So I've programmed up some of the GPS buttons. I've got the screen mounted correctly now. Just do a quick demo. The problem with this is, although it looks pretty good to me, it's really difficult to capture this on video. Everything's reflecting off everything else, so this may not actually look great. We'll see how this goes. So I've got GPS on, power on off, so that's programmed. I've got the rotaries programmed, so if I switch to the first page is the current airport, and I can look at what we know about this airport. If I go back, second page is the nearest airport. So I mean, it's currently programmed up to 30 OR direct to, but if I select a further away airport, so I'll press the cursor, I can go down to, what have we got? OR 27, that's 13.7 miles away. So we go enter. Let's say we want to set a direct to. Press direct to, activate, enter yes. Twice for some reason, I can't remember why that is. And then we can go back to the main page. We've now got a course to direct to OR 27. So that's basically it. I won't show you too much more. I've got the radios programmed as well. I'm changing the frequencies there, swapping between com and nav. But there you go, just a taste of what's to come. This weekend I've mostly been occupied with this baby. If you've been watching right back to the start, you'll recognise this is the first panel I constructed. Doesn't look a whole lot different, but it is. The first thing I've done is taken it apart, dismantled it completely and rebuilt it. It's now got paper insert instead of the acetates. It's nice and flat, which it wasn't before, and I've managed to get rid of the cracks on the front. Now I didn't replace the acrylics, all I did was swap the front and the back acrylic, so that's a good start. I mean, that panel's looking a lot better than it was. The other thing I've done is I've wired it up, and I've done the umbilical cable as well, so it's ready to rock. I've just got to plug this in. I've wired the umbilical up. It's getting pretty crowded inside that wiring box now. What you might notice, if you've got a keen eye, is there's only one hole left in the side of the box, which means there's only one umbilical left to come in, one panel to go. If you've got an even keener eye, you probably spot that there's only 31 switches, inputs available. One final Bodner board, which has got one wire plugged into it so far, and unfortunately I've got 35 signals on this last panel. Not quite sure how I'll deal with that, and then I'll be truly flyable. Everything else, with the exception of the fuel panel, I can do without. So what I'll be missing is the test panel, all the rotaries for setting the bugs and so on. But that's navigation stuff. I can do without that and fairly convincingly fly it around and even navigate using the GPS panel. I've worked out the shift on the rotary controls as well. It ought to be possible to do that. I've described the shifting in another video. It's the turn versus push and turn. The push is the shift key. I did figure out you can do that in Linda, at least in principle, but in practice that seems to be buggy. I've read reports that there's problems with the shifting. So I've worked out a different way to do that. I've implemented that myself using a little bit of Lua code, and it works. Brilliant. So all the rotaries, I've got shift functions on those, so I've got fast and slow. So we're ready to go. Once I've got this panel wired up, well it is wired up, once I've got it just checked out, I've got rudder trim, got parking brake, I've got the yaw damper, and most importantly I've got the autopilot manual mode controls. So it's going to be freaking awesome, you've got to say. You might recall me a couple of blogs back mentioning that I was out of inputs on the Bodner boards, so I was going to have to make compromises with some of the buttons. Well, that's kind of got worse because I've more or less decided to use a rotary control for the rudder trim, so that's 3 more buttons, and I was already short of about 3 or 4 inputs. And I've also discovered some extra functions that I need, for example the wing fuel tanks, which I didn't know about. Well, I kind of knew about it and didn't think that was implemented, but so I've got another 2 toggle switches. To cut a long story short, I've decided to go for yet another Bodner board, so that'll be 6 boards. So once I decided to do that, I went ahead and made another panel. Now, there's a few interesting things to say about this panel. I already made this earlier. It's made out of MDF. It's not an acrylic panel, and it was basically just a blank panel with that sticky backed plastic on, and it fits around the elevated trim control. It fits next to the lower console. Well, I've got the ADF tuning function on here, and what I've done is I've also duplicated 3 of the buttons from the ADF control panel. That's the flight time, elapsed time, set reset, and also the FRQ frequency button. So that allows me to manipulate those ADF tuning controls whether I'm using the timer. I can swap back and forwards between the timer functionality and the frequency tuning. Then I've got a control lock function. It's not very realistic, but it's on a toggle switch there. I've got the wing tank fuel boosters, and I've got gear up and down for the amphibious versions. Anyway, I got the last 2 panels wired up, so we're finished with the soldering. At least we're finished as long as these 2 were. I haven't tested these 2 yet, just finished them this weekend. That's the fuel and etc. panel, and the little one that I showed you last time, including the additional dual concentric control. You know, one of the things that's not really apparent at the outset is that this is an almost industrial scale kind of project. You know, I started off with this really naive idea that I could do this by just buying a couple of those VR Insight boards and hanging them overhead or dotting them around and then programming up the buttons and switches. But you know, when you count things up, this cockpit that I've built's got 137 components. This is not counting the analog controls. Just buttons and switches. There's 137 separate components across all the panels, and that's a total of 179 switches. And another surprising fact, you know, I've used about 350 meters of this wire. I shudder to think what this is going to add up to when I count up the cost of this. You know, the other thing about a project like this, which is worth mentioning, is it's not just about the product. You know, if I could have gone into a shop and bought all of this stuff in one go, I probably would have done it. But it's nothing like the same thing. I've come out of this with, I suppose, a better understanding of the systems and so on, although it's still a fairly rudimentary understanding until I start flying this thing around. But it's just been fun. I mean, I've just enjoyed doing it. It's been, you know, I've put a lot of my spare time into this for the last 4 months. It's the Garmin I have no idea what it's called. GNS. This will be edited out. What is it? Come on. Okay. This is quite a sophisticated unit in this implementation of the Twin Otter. It's the Garmin GNS. Oh, I've forgotten again. So this is the lower console, middle. Yeah. I think I'll start that again. Yep.